Autism and Parkinson's disease are two conditions in which differences in movement have been observed. Studies have provided evidence for increased jerk and number of sub-movements in both conditions compared to the general population, but a distinction in the direction of difference for speed and acceleration, with increased values in autism and decreased values in Parkinson's disease. Previous studies have extracted movement kinematics from participants' drawings of elliptical shapes. This overlooks the full range of available shapes, which can each be defined by their angular frequency, or the number of curvature oscillations per unit angle of theta. We know that individuals in the general population adapt their speed as a function of curvature, but importantly, the gradient of this adaptation is dependent on the shape's angular frequency. Inappropriate adaptation of speed as a function of curvature may explain problems with handwriting in autism and Parkinson's disease, and therefore it's important to investigate this gradient in addition to other kinematic variables across a range of shapes with different angular frequencies. Such investigations are of great importance considering recent reports of an increased prevalence of Parkinson's disease within the autistic population. As Parkinson's disease is often diagnosed based on motor function, similar movement profiles in autism may explain these higher levels of diagnosis. This study will conduct the first direct comparison of autistic and Parkinsonian movements using a matched groups designed to investigate a range of kinematic variables at different angular frequencies. Autistic individuals, individuals with Parkinson's disease, and control participants matched for age, gender, and non-verbal reasoning will be recruited, with 30 in each group. Participants will complete demographic information, questionnaires, and a non-verbal reasoning task, in addition to a shapes tracing task in which 4 shapes will be traced on a touchscreen device for a total of 12 trials per shape. Individuals with Parkinson's disease will complete the tasks both on and off dopaminergic medication. Kinematic variables will be extracted, including velocity, acceleration and jerk, sub-movements and beta scores to quantify the adaptation of speed as a function of curvature. Linear mixed models will be conducted on each of the kinematic variables, with group and shape as fixed factors and trial number and participant number as random factors. We expect to find increased jerk and number of sub-movements for the ASD and PD off groups in comparison to PD on and controls. However, we expect to see increased and decreased velocity, acceleration and beta values for the ASD and PD off groups respectively. Our analyses will also reveal whether kinematic variables vary along the angular frequency spectrum and whether this variation is different for each group. I'd be really grateful to hear any comments or suggestions that you have for this research plan.